Welcome. Today we are continuing with Physics Paper 1, Section B, 55 marks. Kindly subscribe. Question 14. An object is fired vertically upward from a ground level with a velocity of and reaches a maximum height. It falls back to the ground and bounces to a height of. Sketch a velocity time graph to represent the motion of the object from the time it is fired till it bounces to the height. This is now at the sketch of velocity time graph. Question B. Calculate the maximum height reached. Maximum height reached. Question 14C. The figure below represents a wheel and axe used as a machine whose efficiency is 80% to raise of building materials. The wheel at the axle has diameters of 75 centimeters and 15 centimeters respectively. Mark on the correct position and direction of the load to be lifted. This is it. Roman 2. Name the principle on which this machine works. It's the principle of work. That is, work output is equals to work input. Roman 3. Calculate the effort needed to raise the load. This is how you calculate the effort. Roman 4. The machine is operated manually and raises the load to a height of 5 meters in 20 seconds. Calculate the power developed by the operator. Question 15A. State what is meant by the term specific latent heat of vaporization. The amount of heat energy required to convert a unit mass from a liquid state to gas state at a constant temperature. Question 15B. In an experiment to determine the specific latent heat of vaporization of water, steam was passed into water contained in a well-lugged copper calorimeter. The following measurements were made. Mass of the calorimeter, initial mass of water, final mass of calorimeter plus water plus condensed steam, initial temperature of water plus calorimeter, final temperature of mixture. The specific heat capacity of water is equals to, and the specific heat capacity of copper is equals to, determine heat gained by the calorimeter alone. This is it, right? Determine heat gained by water only. Here it is. Given that L is the specific latent heat of evaporization of steam, write an expansion for the heat given out by steam. Determine the value of L. Question 15c. Steam 8 was passed for some time into ice 8. At the end, temperature of water obtained was, and its mass. Calculate mass of ice used. Question 16. Define a radian. The angle subtended at a center of a circle by an arc length of a circle which is equal to the radius of the circle. 16b1. Three masses are placed in a rotating table at distances 6 centimeters, 9 centimeters, and 12 centimeters, respectively, from the center of rotation. When the frequency of rotation is varied, it is noted that each mass slides off at a different frequency of rotation of the table. Table 1 shows the frequency at which each mass slides off. State two factors that determine the frequency at which each mass slides off. Friction force and the size of the mass. Oil lowers the friction force. The lower the friction force, the lower the frequency, because the frequency is directly proportional to the force that overcomes friction force. Question 16c. A marked point on a rim of a wheel has a linear velocity of. If the rim has a radius of, calculate the angular velocity of the point. Calculate the centripetal acceleration. The figure below shows a bucket filled with water moving round in a vertical circular path of radius. If the mass of water is 5 kilograms and the speed of the bucket is, show by calculation that this net force is greater at point A than at point C. Question 17. The table below shows the volume V of a certain mass of gas at different temperatures T obtained in an experiment to verify Charles' law. Draw a setup of apparatus that could be used to verify the law. That is the setup. B1. Plot a graph of volume, y-axis against temperature. Did you understand? Kindly let me know in the comment section below. So let me know what video you can look at tomorrow. Thanks a lot for subscribing and listening to me. God bless you.